All right, hello, Algebra 2. So we are going to go on and do Unit 9.3, which is on probability of independent and dependent events. All right, independent events, the probability of event A, so that's the first thing, has no effect on the outcome of the probability of event B. So for example, if a coin is tossed twice, the outcome of the first toss, it could be heads or tails, has no effect on the outcome of the second toss because it could be heads or tails. All right, so we can toss the coin, and then its effect doesn't matter what happens, what we get on the first toss isn't going to affect what we get on the second toss or the third toss or the fourth. So what we do is we take each of the probabilities separate and multiply them together. All right, so if A and B are independent events, the probability of A and B is equal to the probability of A times the probability of B. So we just multiply the two probabilities together. All right, so then dependent events, the probability of event A has an effect on the probability of event B. All right, so this one, whatever happens on the first probability is going to affect the probability of the second one. So for example, finding the probability of picking an ace from a deck of 52 cards, and then not putting that ace back in the deck, and then picking a queen. All right, so by not putting that card back in the deck, it's going to affect what the new probability of picking a queen is going to be. So if A and B are dependent events, probability of A and B is equal to the probability of A times the probability of this B slash A. So it's what that means is A is affecting B, or B is being affected by the probability of A. Right, so that's what that slash means. It doesn't mean a fraction. Right, so that's just a symbol. All right, so determine if the events are independent or dependent. Right, independent or dependent. All right, so test grades and final grades. Are test grades and final grades independent or dependent of each other? All right. Well, the semester grade, that's your event B. Test grade is event A. So is B affected by A? Well, yeah, what we get on our final grade is dependent on what we get on our test grades. So we would say they are dependent. Just write a D. All right, part B, selecting a red marble, then a blue marble from a bag of 2 blue and 5 red without replacing the first marble. All right, so we have a bag of marbles. We're going to pick a marble out, and then we're going to leave it out. We're not going to put it back in. All right, so that's going to, what we get on the second draw, because we're not putting that first marble back in, it's going to be dependent. And then C, selecting a blue marble, then another blue marble from a bag of 2 blue and 5 red. But this time we're going to replace that first marble before we take the second one. So these are going to be independent events. So the second draw, or the second marble that we pick, isn't being affected by what happened on the first one. And that's because we're going to replace that first marble before we pick the second marble. All right, so let's look at this example 1, probability of 2 independent events. All right, so these are independent, so you can see another example. You're playing a game of spinning the wheel. All right, kind of like on Wheel of Fortune. You get to spin the wheel twice. What's the probability? You get more than $500 on your first spin, and then go bankrupt on the second. All right, so the first thing I want to do is find the probability of getting a number that's more than 500. Right. So more than 500. So the probability of, we could say greater than 500. Times the probability of going bankrupt. Okay, we'll call it B. All right, so let's count up all the ways that we can get greater than 500. And I think they're labeled on this for you. So it looks like all the A's on here are going to be greater than 500. So 1, 2, 3, 4, 5, 6, 7, 8. And then we got to figure out, well, how many numbers are there even on this wheel? Okay. So there's 24. So we have a probability of 8 out of 24, or 1/3, of getting something greater than 500. Times, now we want to find the probability of going bankrupt, and so we can see that there's 2 bankrupt. So we have a 2 out of 24. So what happened on the first spin is not going to affect our second spin. They're independent of each other. All right, and then we can go ahead and simplify this. Here, I'll just do this as fractions. So it's going to be 1 out of 36. And if we want the decimal, we can get the decimal or the percent. So let's say 1. So 0.028, or 2.8% chance of that happening. All right, example 2. Find the probability of selecting an ace, then a red king without replacing the first card. Now, because we're not replacing that first card, the second probability is going to be affected by what happened on the first probability. So these are going to be dependent on each other. So this is a dependent event. So find the probability of selecting an ace and then a red king without replacing the first card. So the probability of getting an ace and then we're going to multiply that by the probability of getting a red king. All right. So let's see. All right, so probability of getting an ace is a 4 out of 52. All right, so we have to assume that we pulled an ace out. Okay, so there's one ace in our hand, and we're not going to put it back in the deck. Right, so kind of think it's off to the side. Now we want to find the probability of getting a red king. All right, so now how many red kings are there? Well, there's 2. There's the king of hearts and diamonds. But there's not 52 cards in the deck anymore. There's only 51 because I have to assume I pulled that ace out and I didn't put it back in the deck. So there's only one ace that is not in the deck. All right, and then I can go ahead and simplify this down. Let's see. Let's go 13 times. And then go ahead and multiply across. 13 times 51. So 663. All right, so we have a 2 out of 663 chance of that happening. All right, example 3. You randomly select 2 cards. What's probability the first card is not a face card, and the second card is a face card? Right. You replace the first card before selecting the second on part A, and then part B, you do not replace the first card. All right, so on part A, these are going to be independent, and then part B is going to be dependent. So put an I for independent and a D for dependent, just so you can see the difference. All right, so let's go ahead and do the first one. Probability of the first card is not a face card. So we have to figure out in a deck of cards how many cards are not face cards. Well, we know that there's 12 that are, and there's 52 cards, so that means there's going to be 40 that are not. So there's 40 cards that are not face cards. Times. And then the probability of the second event is it is a face card, so there are 12 face cards. All right, and then we can go ahead and just multiply those together. So it's going to be 30 over 169. All right, and then part B, you do not replace the first card. So again, we're going to start the same way, 40 out of 52. But now we have to assume that we pulled one of the non-face cards out. You know, it could be an ace, it could be a 10, it could be a 6. So one of those cards is not going back in the deck. All right, and then we want to pick a face card. There's 12 face cards, and now there's only 51 cards. All right, so now we have 40 out of 220. All right, example 4. You have a bag of marbles, 4 green, 3 blue, and 2 red. Part A, what's the probability of picking a green marble, replacing it, and then picking another green marble? And then part B, finding the probability of picking a green marble, not replacing it, and then picking another green marble. All right, so let's go ahead and do the first one, probability of picking a green marble. Well, we know there's 4 green. And then there's a total of 9 marbles in the bag, 4 plus 3 plus 2. We're going to take that green marble, we're going to put it back in the bag, and then we're going to pick another green marble. So it means that we have another 4 out of 9 chance. And we can multiply those together, 16 over 81. Part B was probably picking a green marble, again, 4 out of 9. We're not going to put that green marble back in the bag, and now we're going to pick another green marble. Since we have a green marble that's left out, there's 1 less green marble to pick from, and there's 1 less total marbles in the bag. All right, so we have a 3/8 chance on that second one. All right, so then multiplying these together, let's cancel, and so it's a 1 out of 6. All right, example 5, you're tossing a two-sided coin. What's the probability of tossing a coin 3 times in a row and getting heads all 3 times? All right, so the probability of getting heads the first time is a 1 out of 2 chance. Probability of getting heads on the second flip, a 1 out of 2 chance. And probability of getting heads on the third one is 1 out of 2 chance. So these are all independent of each other. So we just multiply across, 1 out of 8. B, if a coin is tossed 4 times in a row and heads come up all 4 times, what's the probability of the next toss showing heads? Right, so since each event of flipping a coin is independent of each other, then we have a 1 out of 2 chance that heads is going to come up on the fifth toss. All right, and then this last one, example 6, imagine there's 2 groups. A member in each group gets randomly chosen for the winner circle. Then one of those gets randomly chosen to get the big money prize. What's your chance of winning the big prize? All right, so we have these 2 groups. So you can see in the diagram. And in our group, there's 5 people, and one of those 5 is going to win. All right, and so we have a 1 out of 5 chance, if that's us, of winning in that first group. So now we go over to the winning circle, and there's 2 people, and one of those 2 people have to win. And so now there's a 1 out of 2 chance of winning in that group. And since they're independent events happening here, we're just going to go ahead and multiply these together, and then we have a 1 out of 10 chance of actually winning. Okay, and that's it.